These days, businesses capture a significant amount of data, and it's really difficult to service all of the operational, analytical, and data storage needs using centralized warehouses. Distributed systems grew in popularity in the early 2000s with the growth of the internet and the consequent explosion of data. They are designed to store and serve large amounts of data in a reliable and performant manner, which is why most modern enterprises use them for operational and analytical purposes. A distributed system is a system whose components are located on different computers that are connected through a network. Each node in a distributed system communicates with the others by some form of message passing. In the context of big data, the primary application of a distributed system is to store and analyze data by splitting analytical tasks and data across different computational nodes in a system. One of the key benefits of using a distributed system for big data applications is that you can rely on commonly available computers to set up a distributed system that can be easily scaled out by adding new nodes as the size of your data increases. Now that we have a general idea of a distributed system and how they can be applied to big data, let's look at some of the key hardware components that determine its performance. The first piece is the CPU, or the Central Processing Unit, which is the brains of a computer. It is used to direct other components and to execute instructions from different processes that are running on the system. The next piece is the RAM. RAM is used to store instructions from processes that are currently being run by the system. These instructions can be directly accessed by the CPU for execution. One issue with the RAM, however, is that it is typically volatile. This means that the data in it does not survive system restarts. But on the plus side, it is much faster to read and write data on the RAM than the next piece of hardware, which is the secondary memory. Most of the storage on a computer is provided by the secondary memory, often in the form of a magnetic hard disk, and in newer systems in the form of more expensive but faster solid-state drives. The benefit from secondary memory is that the data in it is persistent and does not get erased during restarts, like in the case of the RAM. However, this comes at the cost of speed. The RAM, for instance, is on average about 15 times faster than an SSD. As a result, systems that are designed to reduce and optimize secondary disk access will be more performant. So far, we've looked at hardware that is present locally within each node in a distributed system. The next piece is the network, and it connects all the nodes in a distributed system. It is by far the slowest piece of hardware in a distributed system. As a result, sending data across the network from one machine to another is one of the more common bottlenecks in a distributed system. And the best way to address this bottleneck is by reducing the amount of data shuffling across different nodes in a system. Kinetica adds two additional components to the list of hardware found in a traditional distributed system: the GPU and the video RAM, or VRAM in short. In terms of speed, the GPU is the fastest of all the components, while the VRAM is faster than the RAM. The GPU, or the graphical processing unit, is designed to perform lots and lots of similar computations in parallel, usually for rendering graphics. We will explore the features of a GPU and its application to data processing in more detail in a later video. But the key thing to remember about the GPU is that it is built for raw throughput and speed. The video RAM, or VRAM, is memory that is dedicated for the GPU. It is separate from the system memory, or the RAM, and is designed to have a high bandwidth so that it can support the high throughput of a GPU. So to summarize, there are two key bottlenecks that we need to be aware of when dealing with distributed systems. The first is accessing disk-based storage. Reading or writing data using a hard disk is much slower than the RAM and should be limited when possible. The second and most significant bottleneck is the network, or to be more specific, transferring data between different nodes in a distributed system over the network. This is by far the biggest bottleneck in a distributed system and should be avoided whenever possible. Reducing these two bottlenecks is a key consideration for the design of distributed systems. For instance, Kinetica's tiered storage and resource management features help keep more frequently used hot data in the VRAM and RAM, as a way to avoid unnecessary movement of data to and from a hard disk. While features like sharding and chunking help distribute and organize the data in a way that reduces unnecessary movement over the network.